Today we will study about equations of uniformly accelerated motion. First equation of motion is v is equal to u plus at. It gives the velocity acquired by a body in time t. So in equation we can write as acceleration is equal to change in velocity by time taken, or acceleration is equal to final velocity minus initial velocity that represents the change in velocity divided by time taken. By notation, it is A is equal to V minus U by T. That is AT is equal to V minus U. So V is equal to U plus AT. This is our first equation, where V is equal to final velocity of the body, U is equal to the initial velocity of the body, A is equal to the acceleration, T is equal to the time taken. So this is our first equation of motion. Now we will see it in graphical representation. Now we will learn about how to derive this equation V is equal to U plus AT by graphical method. So this is the velocity time graph. In this graph we will derive the equation V is equal to U plus AT by two axes, that is usual x axis which represents the time taken, and the y axis which represent the velocity of the moving body, and the vortices will decide the instants where we are going to recognize the velocity, initial velocity, final velocities, and the distances between these vortices will decide the time, velocity, and slope is represented by some rise by rho. This will decide how we will get our equation from this graph. So in this graph, let us look at this point. This is O. This is the origin of the or the initial point of the body, where velocity is 0 as well as time is also 0. So when we are considering the point that is A, where the time is 0 but the body is already at a velocity that is u. From this velocity the body is moving to get a velocity that is v. This is v. This velocity at the point B, the velocity of the body is v. That is the final velocity. Now we have to derive this equation. In this equation we have v u, that is initial velocity, v is equal to final velocity, a is equal to acceleration, and t is equal to time. So when we consider u, we will consider this point OA. OA, this line represents the initial velocity u, because it is only in the y-axis or velocity axis, and here the time is 0. So A is the starting point from which we are considering the motion. Then comes V. V is the final velocity at point B. So its length on the y-axis, the length of the point B in the y direction is representing the final velocity V, that is BC. So V is equal to BC. We know that V is equal to BD plus DC from this graph. So V is equal to BD plus DC, or V is equal to BC. BC is equal to BD plus DC, that is V is equal to BD plus DC. We know that DC is equal to OA. So BD is equal to OA. OA is equal to U. So we can write V is equal to BD plus U. Now we have to get what is BD. So for this we have to consider the slope AB. In this triangle the slope AB is representing the acceleration of the body. We know that the slope of a triangle is equal to rise by run. Slope is equal to rise by run, not the length. So we are here considering the slope, that is equal to acceleration. So acceleration is equal to the slope of the line AB, that is rise by run or BD by AD. So slope is BD by AD. We know that BD is equal to BC minus DC, that is V minus U. This is the change in velocity, and AD is equal to the time. So A is equal to V minus U by T. So BD is equal to AT. So V is equal to BD plus U or AT plus U, or we can write this as V is equal to U plus AT. This is our first equation of motion by graphical method.